Measuring the atmospheric pressure has several applications. Obviously, if you're a meteorologist, knowing the pressure at a geographical location helps forecasting the weather. But there's more. Simply speaking, atmospheric pressure is the weight of the air above an object. As the height of a column of air above an object changes depending on its altitude, so does the weight of that column. Atmospheric pressure at the surface of the sea is higher than that on the top of a tall mountain. Therefore, measuring the atmospheric pressure is also a simple way of figuring out your altitude, or the altitude of one of your flying gadgets. The standard unit of measuring atmospheric pressure is PA, or pascals. At sea level, the standard pressure is defined to be 101.325 kilopascals. We will be measuring atmospheric pressure by using the BMP085 sensor. This sensor costs around $8 on eBay. It can measure pressure from 300 hectopascals to 1100 hectopascals, which converts to around 500 meters below sea level to 9,000 meters above sea level. Its accuracy is also excellent, around 0.03 hectopascals. Another nice thing about this sensor is that it also measures the temperature. The BMP085 talks to other devices via the I2C interface, a digital serious communication interface that only needs 2 wires for communication and 2 for power. One communication wire is called SDA and it transmits data, while the second, SCL, is for the clock signal. A clock signal is needed because I2C is a synchronous interface. This is a circuit we're going to be putting together. We'll need the Arduino, 4 jumper wires, and the BMP085 sensor. The wiring is very simple. If you remember, in lecture 8, we connected a humidity and temperature sensor and we included a pull-up resistor. We don't need this resistor now because it is included within the sensor's package. That's one less thing for us to do. Have a look at the assembly demo. This is the sensor. At the back, you'll see the markings that indicate the purpose of each pin. Plug it into your breadboard. Take the red wire and plug it into 3.3 volts. Be careful, if you plug it into the 5 volt socket on the Arduino, you are going to likely damage the device. Take a black wire and connect the ground socket on the Arduino with the ground socket, with the ground pin of the device. Take a yellow cable and connect it to the analog socket 4 on the Arduino. And a green cable to analog socket 5. Now upload the sketch from your computer to the Arduino. Bring up the monitor. And this is what you see. Just like in lecture 8, to use a barometric sensor, we include an external library in our sketch. This comes again from Adafruit, and you can find it on GitHub. Follow the instructions in the README text file for setting it up, and don't forget to restart your Arduino IDE. The sketch itself comes straight out of the examples that I included with the Arduino IDE. Let's go through it together. First, you need to include the wire.h library, which allows for I2C communications to happen. And then you also include the Adafruit library. Look at the instructions if you're unsure about how to do the connections of the sensor with the Arduino. define a variable to refer to the Adafruit BMP085 library. Initialize serial communications. And then try to start the device. If the device isn't starting, then print a message so that the user knows about it. Maybe they haven't connected it. If everything goes well, then the Arduino will call the loop function and start running through the instructions in it. First, take a measurement of the temperature by saying bmp.readTemperature, where BMP is a reference to the BMP device handle. And we'll do the same thing for the altitude and pressure. The nice thing about this device and the library specifically is that we can calibrate the read altitude instruction so that it can be custom to our present conditions. For example, if we are at a location where there is some weather patterns that are unusual, then the pressure at sea level will be different to normal, and we can tell the device about that by adjusting it. And here's the monitor output once we run the sketch on the Arduino. And that is how you connect and use the BMP085 barometric sensor with the Arduino. As always, before moving on to the next lecture, please try out the questions in the quiz section right after this lecture.